Newton's law of gravitation states that every particle attracts every other particle in the universe with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between them. Consider two bodies whose masses are m1 and m2, and also consider the distance between them is r. According to the statement, F is proportional to the product of their masses m1 and m2, and F is inversely proportional to the square of the distance between them. So F proportional to 1 by r square. By combining these two, I can get F proportional to m1 m2 by r square. To remove this proportionality, I have to keep a constant, and this is G m1 m2 by r square. This constant G is called universal gravitational constant, and its value is 6.67 into 10 power minus 11 Newton meter square per kg square. You don't worry about the units. So you can derive the units using the formula. The force of attraction between these two bodies is given by G m1 m2 by r square. From this, I can write the equation for universal gravitational constant as G is equals to F dot r square by m1 m2. So units of G are, F is measured in Newton and r is the distance, so it should be measured in meters. So it is meter square per, these are two masses, so kg into kg, I can write it as kg square. So in this way you can derive the units of any physical quantity. Now let's apply this equation. Simple example. Consider two bodies whose masses are 2 kg and 4 kg, and these two are separated by a distance of 2 meter. And now I am going to find out the force of attraction between these two. F is equals to G m1 m2 by r square, implies F is equals to 6.67 into 10 power minus 11. M1 is 2 and m2 is 4 by r square. So it is 2 whole square. 2 whole square is nothing but 4. So this 4 and this 4 gets cancelled. You will get F as 2 into this much. 2 sevens are 14, 13, 13. So it is 13.34 into 10 power minus 11 Newton. While doing calculations, you must take care to substitute the values, because the units should be in the same format. Maybe here kg, meter, these three are in SI system. Sometimes you may not given all the units of given physical quantities in the same unit system, so they must be made into the same system of units. But here one question is given, how the force of attraction between two bodies changes if mass of one of them is increased twice and the distance between them is halved. For this, let us consider the masses of two bodies are m1 and m2, and the force of attraction between them is given by G m1 m2 by r square. Now one of these, the mass of one of these is increased twice and the distance is made half. Let us consider the mass of first body in second condition is m1. Take it as small m1 itself, and mass of second body in the second condition is capital M2, and it is made twice, so I can write it as 2m2, and let the distance in the second case is r, and this is made half. So initial distance is r, so made half means it is r by 2. Now let the force of attraction in the second case is F1 is equals F1 is equals to capital M1 capital M2 by capital R square, sorry, and G capital M1 M2 by R square, and I am going to substitute the values. F is equals to capital G, and capital M1 is as usual small m1, and it is equals to 2m2 because the mass of second body is increased twice, and the distance between them is capital R square, so I can substitute as R by 2 whole square, which is equals to, I'm going to keep this 2 outside, 2 G m1 m2 by, keep it this R square as it is, and by you have 4. Now this 4 moves up, so capital F1 is given by 2 into 4 8 G m1 m2 by small r square. I can write it as F1 is equals to 8. What is G m1 m2 by r square? This is nothing but the initial force of attraction dot F. The force of attraction in the second case is F1, which is given by 8 dot F, where F is the force of attraction in first case, means the force of attraction increased 8 times if the mass of one body is doubled and the distance between them is halved. So increases 8 times.